students, let us continue our lectures under probability. Today in this video, I would like to discuss about a famous theorem called addition theorem. Addition theorem, or also called addition rule. Addition rule on probability. It's very simple to understand. So let us take two events of your choice. Let us take A and B. They are joint events because common portion is there. So some outcomes will be common between A and B. Let us take a few outcomes in A and B as follows. Suppose if I'll take here A1, A2, A3, A4, A5. There are 5 outcomes in event A, and when I write any outcome in this portion, the same outcomes will be there for B also. Let us designate the remaining elements B1, B2, B3, A3, A4. One more thing as before. So here 5 outcomes there, 1, 2, 3, 4, 5, 6. 6 outcomes of B are there. The theorem states that we can write number of elements in A or number of outcomes in event A is equal to 1, 2, 3, 4, 5, and number of outcomes in event B is equal to 1, 2, 3, 4, 5, 6, and the number of outcomes in both the events A and B. We can write A and B. In symbolic form, we can write number of elements of A intersection B. That is equal to, only 2 are there, it is 2. So first you have to identify outcomes are there, how many they are going to appear in each event. Now theorem states that probability of A union B, that means that is equal to probability of the event of A outcomes or event B outcomes may appear, any one of those two, A or B, is given by probability of the event A plus probability of the event B minus probability of event A intersection B. Why we need to subtract this? The thing is that if you look at this part, A1, A2, A5, they are only present in A part. A3, A4, A and B part, B1, B2, B3, B4, only B part. So based on this view, we get this rule called addition theorem on probability. I will explain in simple concept shortly. So this is a simple way to explain addition theorem. So I took instead of elements there, P1, the outcomes which are there only in this part. P2, both the events. P3 only in part B without including in both. So if you want to find probability of the outcomes A or B, that you can write as probability of A union B. So to get total outcomes in these two circles, just you have to add these three, P1 plus P2 plus P3. On adding these three outcomes, we get complete outcomes either in A or in B or both. But what is P1? It is complete circle of A. We can write probability of A, right? Minus this part, probability of A and B. plus P2. P2 only this part. So we can write probability of A intersection B. This is your P1. This is your P2. Next P3, same like P1, probability of B, minus this part, probability of A intersection B. You see, we can cancel off one pair of A intersection B. The leftover is that we are going to get probability of A plus probability of B minus probability of A intersection B. This is the addition theorem on probability to compute whenever events overlap. This plays a vital role. This theorem plays a vital role in many word problems to compute probability for getting A or B. Do share and subscribe our channel. Next video onwards, we are going to get a problematic view. So it may be a time consuming process. The same problem may be break down into 2 or 3 videos so that how to work out lengthy problems in probability, you get the idea based on the theorems what we are going to cover. All the best.